The front end is what you see in your browser, and it's what you most commonly think of when you see a website. While simple websites can be made with just HTML and CSS, which stand for Hypertext Markup Language and Cascading Style Sheets respectively, JavaScript is used to build more dynamic front ends and also link them to server-side code called the back end. JavaScript includes technology called AJAX for dynamically updating parts of a web page and uses 4 basic operations for managing data. These operations are create, get, update, and delete. In addition, there are frameworks or ready-made sets of code that make it easier to develop software. Many frameworks such as Angular and React and JavaScript and Jinja and Python are used to generate web pages using the same object-oriented principles that are used in other forms of software development. React has become very popular in the past few years and is based on using JavaScript to power XML. XML stands for Extended Markup Language and is an extension of HTML. React is an object-oriented framework and is based around components as the base object type and supports state management with each one. Many add-ons, such as Redux middleware, allow for easier management of shared data between components by using a common data store for the entire web app. These dynamic web pages come together to form web apps and can interface with the backend to handle data alongside handling data on their own. Much user-facing logic is handled entirely on the front end, including interactive elements of increasing sophistication on a web page. Recent advances include WebGL, which allows 3D graphics to be embedded directly into a web page without relying on browser plugins.
So now that we know that the front end is what you see and how you interact with the app, it's time to get into the back end. The front end is delivered to the client via the back end, and all inputs are processed by the back end. Typically, the back end is a conglomeration of the server, databases, APIs, and the operating system that powers an app's front end. The back end is a very diverse system that can look very different depending on the app. An example of back end work is a user enters a URL, clicks a link, or submits a form, and the browser connects to a web server. The web server runs software that delivers resources like web pages or images. So the browser sends a request to the server when you click a button, and the server responds by delivering the proper resource. The backend developer programs the server to respond with the correct resource. The backend developer writes code to pull information from a database. Backend developers typically work very closely with front-end developers. Some responsibilities of a backend developer would be writing APIs, writing code to interact with the database, creating libraries, or working on business processes and data architecture and much more. Backend developers are in charge of handling user data, so they store that data and make sure it's only accessible for those it is meant for. They are in charge of writing code to process payments, like when you provide Amazon with your credit card so they can charge you for a purchase. Backend developers create APIs, which is a set of functions that allow applications to access data and interact with an external software. An example of this is logging into websites using your Facebook account. This leverages Facebook's API to authenticate the user with each login. There's object-oriented backend development, and there's functional backend development. Some programming languages that a backend developer might use include Java, Python, C#, SQL, Ruby, JavaScript, and much more.
Alright, let's move on to databases. Databases can be considered as large containers of information. This kind of information can be like names, birthdays, links to photos that are stored on the cloud, and the list can go on and on. One of the main aspects and concepts of a database is a schema. A schema, in simpler terms, is a plan on how each set of data in a database will be grouped and organized. The idea becomes much simpler if we think of a database as an apartment complex and a schema as a floor plan of those apartments in that complex. The apartments will all look relatively the same as they were designed on the floor plan, but the contents of each apartment will be entirely different depending on who is living in those apartments. In the world of databases, a schema of a database for students in a school can be a set of data of the student's name, birth date, classroom, and teacher of each student. Moving on from schemas come queries. Queries are commands that are issued to the databases that need to be fulfilled. These commands can be as simple as requesting data from a specific set of data, or a command to add data, or a set of data, or even delete a set of data, and possibly even the entire database depending on the request or command issued. Last but not least is database management systems, or DBMSs for short. They can be considered as the operating system of a database, although there is a lot more to it than that. There are multiple kinds of databases that are split into two categories, SQL and no SQL databases. They each have their pros and cons depending on the scenario or situation. One can be much more efficient than the other. A good example of an SQL database, and I'm sure many are familiar with, is called MySQL. It is probably the most popular SQL database out there. Another popular DBMS, which is a NoSQL database, is called MongoDB, which is a very powerful DBMS, and depending on when you use it, can be a much better option than MySQL.
Now that we have an understanding of how front-end, back-end, and databases work, let's look at some of the different types of websites that are out there. There are informative or practical information websites. The purpose of an information-centric website is to convey specific, helpful information to a specific user or audience, so that the reader learns something new or understands a topic better. We also have entertainment websites. These websites showcase entertaining information for visitors. For example, online magazines, gossip-oriented websites, celebrity news, sports coverage, movies, the arts, humorous websites, etc. These websites are designed to be easy to navigate and frequently updated in order to keep users coming back for more information. There's also e-commerce websites. The purpose of an e-commerce website is to sell products to users. The most successful websites are carefully optimized to achieve a high percentage of purchases. We also have service-based business websites. The purpose of a service-based business website is to convince a website visitor that they should become a customer of the service company. There's also blog websites. The purpose of a blog is to provide a regularly updated website or web page, typically one run by an individual or small group, that is written in an informal or conversational style. Blogs can be started up very easily online using a number of free services, such as WordPress.com. Finally, we have social media websites. The purpose of a social media website is to make it very easy to share and connect with friends, family, coworkers, acquaintances, and even strangers. Social media websites make quick and easy work out of building up a network of connections so as to keep in touch, share daily experiences, photos, interests, preferences, etc. This is how web development works from beginning to end. We are Team POSIXOtters. Thank you very much for watching.